I have been in this finite element simulation arena for over 30 years. And I have seen many things, in this industry. If you give the same model to 5 different analysts, chances are you're going to get 5 different results. And why is that? First of all, when you receive a CAD model, even though you have told the design engineer to get rid of many features, chances are there is still work to be done on your part. And you as an analyst, you need to go and make decisions, what is important, what is not important, and how to defeature your CAD geometry. Once that is done, you still need to go and create a mesh and see where you need a finer mesh, where you need a coarser mesh, how you are going to connect the different parts together, how you are going to apply the loading, how you're going to constrain your model. And different analysts will have different approaches to how each of these steps should be done. Another area that is quite often overlooked is materials. When you're doing finite element simulation, materials is probably one of the most important input that you need to give to the solver, provide to the solver. And how many times have I seen in the consulting projects that I go to customers and they have no clue what the material properties to use for their designs. And I have to go and do a Google search and go to new handbooks and to find the correct properties. Recently, we were doing a scissor lift project, and this scissor lift had several components that are tied together. And how are they connected? You basically have to connect one component to the other component and the direction in which the load path has to go through it. So that's a lot. Many times when you're putting a model together, it involves doing the same type of connection over and over. So that, those are very repetitive operations, and they lead to a lot of errors, human errors. Okay, but let's say that you have overcome all of these and you have gotten some results. So what do you do with the result? Many people may think that the finite element analysis is all about some pretty pictures, but it is not. What we want is to make sure that my design is sound, that I have positive margins of safety. And so how do you calculate the margins of safety? Do you use von Mises stresses? Do you use principal stresses? Do you use nodal stresses? Do you use average stresses or non-average stresses? And each company will have its own process, own procedures to curve results, and then using those results to calculate the margins of safety. So after everything's done, I have good results, and then comes the last stage, which is creating a report. To some people, report is they dredge having to write a report, but it's a very important part of the analysis process.
Thanks for checking out our channel. If you like what you saw, make sure to like and subscribe down below so you don't miss out on any new videos. Follow us on LinkedIn, Facebook, and Twitter for the latest engineering news and information. And to see all of our upcoming events, please visit our website at saratech.com/events.